If x minus a is a factor of a polynomial, then x equal to a will be zero of the polynomial. So you remember it. So that means if it is asked, let's take one example. If it is asked x plus 1 is a factor of these or not, so what will do, x plus 1 will make 0. From there it will give x minus 1. These values you apply here. So x equal to minus 1, if you put here minus 1 cube plus minus 1 whole square plus minus 1 and plus 1. Okay, plus 1. So this will give minus 1, this will give plus 1, this will give minus 1, this is plus 1. So I think it becomes 0. Okay, so this calculation becomes 0 here, 0 here. That means x plus 1 is a factor of this. Next one is asked as a x4 plus x cube plus x square plus x plus 1. Is x plus 1 is a factor of that. So what does it mean? Factor means it is a fully divisible. In other way, see for example 12. 2 is a factor means it is a, you will get an integer number if you divide by that. So this x plus 1 is factor means if you divide by, you know that how to divide. This kind of division you are familiar. If you do that, there will be no remainder. Okay, you will get a perfectly one a factor. That is called factorization. Factorization means then this thing can be expressed as a product of x plus 1 into x cube and that part will come. So that is called factorization. So it is asked here. So to do that, we need not to do the division. Yes, if you do by division method, you will get a perfect. That way also you can prove that x plus 1 is a factor. But here simpler method is the factor theorem. What factor theorem says is, that factor theorem, remember theorem factor theorem says that if you want to test that whether x plus 1 is perfectly divisible by that means x plus 1 is a factor or not, so you have to put x plus 1, that means x equal to minus 1, you have to put here and you check it. If it is become 0 total expression, that means that is a factor. X plus 1 is a factor. So again x plus 1 is a factor means you have to put x equal to minus 1 in this equation, check it, and if it becomes total expression as a 0, then that is a factor. So let us put minus 1 here. Minus 1 to the power 4 plus minus 1 to the power cube plus minus 1 whole square plus minus 1 and plus 1. So this total part if you calculate, this is 1, this is minus 1, this is plus 1, this is minus 1, this is plus 1. So 1 minus 1 0, 1 minus 1 0, 1. So this is given 1. So that means this part is not becoming 0. After putting x equal to minus 1, value is 1. So that means x plus 1 is not a factor. X plus is not a factor of this expression. This is the expression and it is asked whether x plus 1 is a factor or not. So to test that, what have to do, x plus 1 write 0, so x equal to minus 1, with that x equal to minus 1 you have to test it here. That means you have to put this value -1 in place of x. So -1 to the power 4, 3 into -1 to the power cube plus 3 minus 1 whole square plus x is equal to -1 plus 1. So after simplification, what we get? This I get 1. This is -1, so 3 minus 3. This is plus 3. This is -1. This is plus 1. So -3 and plus 3 is 0, and 1 and -1 is 0, 1. So okay, this shows that x plus 1 is not a factor. This is not a factor of this expression. This polynomial. So in this expression, it is asked x plus 1, x plus 1 is a factor or not. So to do that, so we have to put x. So for testing, you have to put x equal to -1. To understand whether this is a factor or not, you have to put x equal to -1 in this equation. Okay. As I told earlier, you can divide this expression, this polynomials, by x plus 1. If you get no remainder, that means you can prove x plus 1 is also a factor. Second method is that, or the easier method is that, yeah, this expression you make it 0 and x equal to -1, and then -1 if you put here, -1 to the power cube, -1 to the power square, minus 2 plus root 2, and here is -1 plus root 2. So this gives -1, this gives also, now 1 square is plus, but as minus is then -1, here minus and minus is plus, and so it became 2 and root 2 plus root 2. So and we are getting 2 and plus 2, and this minus 2 is become 0, but here root 2 plus root 2. Okay, so this root 2 plus root 2 became 2 root 2. So that means x plus 1 is not a solution. So this x plus 1 is not a factor of this. So because after putting the values, this polynomial not become 0. That is, it is not a zeros of the polynomial. That means this is not a factor. Okay, x minus 1 is not a zeros of the polynomial, and that's why this x plus 1 is not a factor of this expression.